Hi everyone, welcome to the episode number 15. Now in this episode, we are going to solve a very famous problem. Okay, and I hope you are enjoying the series so far. If you are enjoying it, do let me know in the comment section for sure. And if you have any feedbacks for us so that we can make changes accordingly, do let us know in the comment section. Okay. All right, now we can start with this problem. So this problem is basically a very frequently asked one. So it is given that we have a keypad phone. Okay, so we used to have those Nokia keypads, Samsung keypads, right, which used to have numbers, as you can see in front of you. So basically there are numbers from 1 to 9. There used to be one hash, one star, and 1 0 as well, if you remember. So these digits, these numbers, they represent certain characters. Okay, and as there are 26 characters and there are only 9 numbers over here, so each digit, each number used to represent more than one character. As you can see, 2 is representing A, B and C, 3 is representing D, E and F, 9 is representing W, X and Y. Okay, now let us say if a person wants to type U, he will have to press the button 8 2 times. Okay, he will have to press it 2 times frequently, tuck tuck. Okay, that's going to give him a U. And if that person wants to type, let's say V, he will have to press the button 8 3 times. Okay, frequently, tuck tuck tuck, he will get V. I hope you remember all these things. If you are a new generation, then you would not have seen such phones, but we have used these phones quite a lot to type messages. And yes, it used to be a pain because the typing speed was very slow. So let's say if you want to type my name, Faraz, then what you will have to do? You will have to type this button 3, you will have to press this 3 times, okay, to get F. Then R, for R you will have to press 7 3 times. Then A, you will have to press 2 once. Then Z, you will have to press 9 4 times. That's what you have to do. Okay, all right, now the question. Okay, so the question is, we are given a string S containing digits from 2 to 9. Okay, we are given a string S. That string S contains digits from 2 to 9. Your task is to find all the possible combinations that the number could represent. All right, so for example, here we can see the example as well. So let us say the given string is 2 3. This is the given string. All the characters in this string are from 2 to 9. So 2 and 3, these are the two characters which are given to us. Now we have to tell the possible messages which we can type using these buttons. Okay, first we have to type 2, and it is not given that how many times we have to type 2. Okay, so we can type 2 once, we can type 2 twice, we can type 2 3 times. If we type 2 once, what are we going to get? We are going to get A. If we type 2 twice, what are we going to get? We are going to get B. If we type 2 3 times frequently, what do you mean by frequently? So basically you have to type them fast, 3 times at once, tuck tuck tuck, then you will get a C. Okay, all right, so similarly if you type 3 once, you will get D, I guess, right? D. If you type 3 2 times, you will get E. If you type 3 times, you will get an F. Okay, so 2 is going to give us 3 options, 3 is going to give us 3 options. Okay, now we have to generate the messages. So what all messages can we generate? So let us say if we are typing 2 only once and we are typing 3 only once, we will be getting A from 2, we will be getting D from 3. So AD is the first output. Okay, next we are typing 2 only once, but we are typing 3 2 times, we will be getting AE. Okay, AE is the second output. Then we are typing 2 once, we are typing 3 times, we will be getting AF. Similarly, we are typing 2 times, we are typing 3 once, what will we get? We will get BD. We are typing 2 times, we are typing 3 2 times, we will be getting BE. Then typing 2 times, typing 3 times, BF. And similarly CD, CE and CF. These are the 9 possibilities. Okay, now how are we going to solve this using recursion? So for this, now let us go to the board. All right, so let us say the given string is 3 7. This is the given string, 3 7. All right, now first of all I need to know that what all characters, what all alphabets are represented by each of the numbers. Okay, so for that I need to save it somewhere. So 2 is going to represent A, B, C. 3 is going to represent D, E, F. 4 is going to represent G, H, I. 5 is going to represent J, K, L. Then 6 is going to represent M, N, O. 7 is going to represent P, Q, R and S. 8 is going to represent T, U, V. 9 is going to represent W, X, Y, Z. Okay, so we need to store this data somewhere. We need to know this. Okay, then only we will be able to generate. So to store this, I just want to write down in the comment section what are you going to use. Okay, you must have some knowledge of data structures, right? You must have used some data structures in the past. Okay, if you know any such data structure which could be used to store them, corresponding to 2 you need to store these, corresponding to 3 you need to store these. If you know any such data structure, do let me know in the comment section. We will come back to it later. Okay, so now 3, 7. Now how to think it in terms of recursion. Okay, so whenever I see this problem, I get the intuition that okay, this is very recursive in nature. How is it recursive? So basically, if somebody returns me the answer, let us say instead of 2 characters, let us say we have 3 digits here, 3, 7, 2, 4. Let's say we have this. Okay, 3, 7, 2, 4. Let us say this is the given test case. Now if somebody returns me the answer for this whole part 7, 2, 4, that these are the messages which you can write using 7, 2 and 4. These are the messages that you can write using 7, 2 and 4. Now my task would be, if somebody returns me the answer for this, my task would be to basically pick up that answer, and in front of those answers, in front of those options, in front of those messages which I am getting through this part, I just need to add D, and I just need to add E, and I just need to add F. Okay, all right. So let us say, now I'm taking the smaller input. Let us say if somebody returns me the answer for the remaining part except the first element, if somebody returns me the answer for the remaining part, so remaining part is 7 only. So for 7 the options are going to be only P, Q, R and S. These are the only 4 options for 7 alone. Okay, if somebody returns me this answer, what I am going to do, my task would be to basically make a copy of that. Okay, to make a copy of it, make 3 copies of it, because I have 3 options for 3, right? 3 options for 3. So make 3 copies. In front of the first copy, add D. Add this D in front of the first copy. So D, 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 D. In front of the second copy, add this E. E, 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 E. In front of the third copy, add this F, 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 F. I got the answer. Okay, so these are the 12 possible messages which I can generate using 3, 7. Okay, so this is what I'm going to do. Basically, I will ask recursion to handle rest of the part, bring me the answer. Okay, in front of that answer, I will make few copies of that answer and add the possible options for the current digit. Okay, all right. So this is one way to do it. Other way is we have already solved such kind of problems. Okay, we are asking recursion to handle rest of the task and then doing our own task. What is the other option? What could be the other option? Do your own task and ask recursion to handle rest of the task. How you can do your own task? So basically give your option here itself. Okay, give your option here itself that okay, instead of 3 I'm going to place a D, instead of 3 I'm going to place an E, instead of 3 I'm going to place an F. So these are the options that you can give and ask recursion to do rest of the task. Now here you are doing your own task first, then asking recursion to do rest of the task. This is much simpler because it consumes basically less space. You are not asking recursion to bring you the entire answer, then you will make copies of that answer and then save it. Instead of that, just do your own task first and ask recursion to handle it. Okay, let recursion handle rest of the task. Don't make copies, don't save it. Just do your task, ask recursion to handle its own task. That's it, done. Okay, In the first approach, where we are asking recursion to complete its task first, recursion will bring us a huge answer, and then we will create 3 copies of that huge answer and then save it. Instead of that, just do one thing: give D. Okay, in place of 3, just give D and ask recursion to do rest of the task. Then come back again. Instead of 3, give E and then ask recursion again to do its own task. Then instead of 3, pass F. Then ask recursion to do rest of the task. So this way you will be calling recursion 3 times. Alright, this is much simple, this is much space efficient, and we are going to code basically the second approach, where we are not asking recursion to complete its task first, rather we are doing our task first and then asking recursion to complete the task. Okay, this way we will end up saving some space. But I will, should I show you both? I guess I have already done this kind of practice in the previous episode. So if you're not aware of it, if you're not aware of the first approach where I'm asking recursion to complete its own task first, you can go back, find that lecture, and then basically look at that approach. Okay, I'm going to jump into the second approach where I'm doing my task and then asking recursion to do its task. Okay, my task means I will have to do 3 tasks now. I will have to do 3 tasks. Okay, instead of 3, I will be passing this D. Instead of 3, I will be passing E. Instead of 3, I will be passing F. So when I will pass D, I will ask recursion to complete remaining task. Again, I will come back and I will pass E, and I will ask recursion to complete the remaining task. I will again come back and pass F. Then I will again ask recursion to complete the remaining task. So this is what I'm going to do. So let us go to the coding part now, and yeah. And I hope you figured out that what are we going to use to store that data. To store that data, you can use a map. Unordered map. And if you're not aware of unordered map, I will provide a link in the description. You can go and read about unordered map. Okay, so once you're comfortable with unordered map, let us start coding it. Unordered map of char, so corresponding to a digit, which is a character. You are storing several characters, right? So several characters means string. Corresponding to a character, you are storing string. Okay, this is the map. So let me put data into this map. So corresponding to 2, you have a string A, B, C. You have these 3 things. Corresponding to 3, again you have several D, E, F. Then corresponding to 4, again you have a lot of things, G, H, I. Then corresponding to 5, again you have a lot of things, J, K, L. Corresponding to 6, you have M and O. Corresponding to 7, you have P, Q, R, S. Corresponding to 8, you have T, U, V. Corresponding to 9, you have W, X, Y, and Z. Okay, your map is done. Now you are done saving the data. Okay, now let us write the recursive function. So that is going to be the void help function. Void help. So basically we will be going one by one to all the digits. So for that, keeping an I over here, then I'm passing the string as reference, and then, so why do we need to pass it as a reference? The simple reason is we don't have to make any changes in this string, right? We don't have to make any changes, and yeah, those changes, like we don't have to create the copy of this s. So this is very important point. This is one of the very important point whenever we are writing a recursive function, right? This help is a recursive function. You should pay attention that whatever data you are passing to this recursive function, can you make that data as reference? Can you pass that data as reference? If you can pass that as reference, always pass it as reference. Why? Because if you don't put this ampersand sign and sign there, it is going to make a copy of it. So when we are going to call this help function from the combinations function, it will create a copy. It will create a copy of the string s. Okay, and when the next time this help function is going to call itself, it will again make a copy of this s. Okay, then it will again make a copy. So as many times as recursion is calling itself, copies will be created. A lot of copies will be created, which is a waste of memory. That's why always pass the data, especially vectors, strings, vector of vector. Okay, in case of integers we can ignore it because integers consume very less space. But when we talk about the strings, arrays, 2D matrices, always pass them as reference. If you can pass them as reference, make sure to pass them as reference only, because as many times as recursion is calling itself, that many times the copy will be created. That is the point. Okay, so this is the string. Now we also need to keep a temporary string to generate the answer, right? So string, let me name it as temp, that is to generate the answer. And finally a vector of string to store the answers as well. Vector of string answer. See, I'm keeping everything as a reference. I don't want to make any copies. Okay, all right. So first of all, do the small task. What is the small task? Okay, one more thing we need to pass. We need to pass this map. Otherwise, how would we know that what are the corresponding characters? What are the corresponding characters in front of a digit, right? So we need to pass this map. And again, I'm passing this as reference. Now, so the current digit is s of I. S of I is the current digit. Okay, and m of s of I is going to give us the entire string. So let us say the s of I, the current character is 2. If the current character is 2, this m of s of I is basically m of 2 is going to give us ABC. It is going to give us a string. So let us copy this string somewhere. String str is equal to this. We are getting the string now, going to every element inside this string. So for int j is equal to 0, j is smaller than str dot size j plus plus. We are going to every character. Now what am I supposed to do? I'm supposed to put this particular character and ask recursion to do remaining tasks. Okay, so I'm putting this particular character. Where should I put it? In the temp, because this is my temporary answer. It is my temporary answer, so I'm doing temp dot push back the current character, that is str of j. Then pushed it back, then asked recursion to do rest of the task. Okay, so help I plus 1 s temp answer map. Done. Recursion will do rest of the task. Now what are we supposed to do now? We made a change over here. We need to undo this change. So temp dot pop back. We are popping out the element which we just inserted before calling recursion. Basically, why are we pushing this element? We are pushing this element because we want to generate the answer, and recursion already generated the answer. We trust recursion, right? We trust recursion. So we inserted a current character. We inserted one element. I will ask recursion to do rest of the task. Now recursion is done doing rest of the task. Then only I will come back to the line number 7. When this particular line number 6 is done, then only I will come back to the line number 7, right? So by the time I come to the line number 7, all the task that recursion had to do is done. So remove this element. Okay, remove it. Next time we will insert another character, and then again do the same process, and then remove that character. Then I will insert another character. Okay, so that's what we need to do. We need to insert a character, ask recursion to do rest of the task, then remove that character. Then again insert another character, ask recursion to do rest of the task, then again remove that character. Then insert the third character, ask recursion to do rest of the task, and then remove the third character. Okay, I guess there are only 3 characters. There's 4 characters also. In case of 9 and in case of 7, there are 4 characters also. That will be handled using this for loop. Okay, now we are done. One more thing is remaining, the base condition. Obviously the base condition is very simple over here. So let's say if we reach till the end, so if I is equal to s dot size, it means we are at the end. Okay, if we are at the end, we can save this answer in answer dot pushback temp. Done. And then return from here. We're done with this. Let me make this vector of string answer. Then again another thing that I need to make is the string temp. Okay, and then we can call this function help I comma s comma temp, then answer, then m, and then return the answer. Let us see if there are any bugs. We will try to resolve it. Unordered map is not declared. The reason is we have not included the header file hash hash include bits slash stdc plus plus dot h. Okay, I was not declared in this. Oh, sorry, this should be 0. All right, it is giving us correct answer. Let me submit this. All right, so now try to imagine the recursion tree. Okay, so try to think of it. Just assume that all of the digits represent only 3 characters. Okay, fine, because mostly it represents 3 characters. So assume that they all represent 3 characters. How would the recursion tree look like? So we will start with a node that is the first character, I is equal to 0. This is the first digit. Corresponding to this digit, there will be 3 characters. So the tree will go like this: one child, second child, third child, right? Okay, so let us say the first digit is 2. So corresponding to 2, we have ABC. So one branch will go to A, one branch will go to B, one branch will go to 3 C. Okay, then again from each of these branch, I will be pointing to 1. Again we will have 3 branches. So it will be a similar kind of recursion tree that we have already seen, but here the children will be 3 in every stage. So it will be a geometric progression with the multiplicative factor, common ratio, the common ratio as 3. Okay, this will be a geometric progression with the common ratio as 3. Initially we will have 1 node, then we will have 3 nodes, then we will have 9 nodes, then 27 nodes, and so on. So 1 plus 3 plus 9 plus 27 and so on. It is going to give us a geometric progression, a GP, where the common ratio is 3. You can find the summation of that GP. We have already done this in the past, so that's why I'm not going to do it again. So yeah, we can estimate that the time complexity is going to be somewhere around 3 raised to the power n. Earlier it used to be 2 raised to the power n, where we only have 2 children, but here we have 3 children. That's why 3 raised to the power n. Okay, so that is the time complexity. Now talking about the space complexity, just ignore all these answers which we have created. Ignore these output answer. Just tell me the recursion, the height of the recursion tree. That is the space complexity, right? The height of the recursion tree. Okay, do let me know in the comment section what could be the height of the tree. Height of the tree, should I answer this or not? I will let you know in the comment section as well. Height of the tree is very simple. Okay, just take an input example, just evaluate draw the recursion tree, look at the height of the recursion tree, look at the size of the recursion tree, try to calculate the number of nodes in the recursion tree. Number of nodes will represent time complexity, height will represent space complexity. Okay, space of the recursion stack. Other than that, we are also using space to store the answer as well, right? So just ignore that. To the interviewer, you can explain it separately, that this is the space used to store answer. This is the space used to create this temp. This is the space used for recursion. You can explain it separately. All right. Let us meet in the next video. Till then, please draw the recursion tree. Let me know the space and time complexities in the comment section. Okay. Write it like this: space complexity, this; time complexity, this, in single comment. All right. I will pick a few comments and I will try to give them a shout out in the coming videos. All right. So take care. Bye bye. Let us meet in the next episode.